Hi everyone. Today we're just going to go through some more examples of u substitution. Just thought it might be helpful to see some more and have a place where you can refer back to get more examples. So nothing new today, just reviewing what we've been kind of working through the last couple days. So I'm going to go ahead and use u substitution, and if you'll notice for number 1 through 5, we just have indefinite integrals. So we're just looking to anti-differentiate, and we're going to have a plus c because we don't have that upper and lower limit of integration. So here we go. To start off, remember we're always looking for what would trigger chain rule. So obviously in here, I don't just have x to the fourth, I have this x to the fourth plus 3, and that would trigger chain rule. So I'm going to pick my x to the fourth plus 3 to be my u. That's step 1. Step 2, we're going to differentiate u. So we're going to find du. And so we're going to get 4x cubed. Our 3 is going to drop out, and then I'm going to have dx. So again, writing that like our differential. I'm just going to see if I can focus this a little more. Okay. Next step is to isolate dx. So I know that dx is going to be 1 over 4x cubed times du. So now we've got the pieces that we need to go ahead and tackle this integral. So this integral is going to be equal to, I'm going to keep my 4x cubed. Now, in parentheses, my x to the fourth plus 3, we said that was going to be u. And I have that to the fourth power. And then our dx, we're going to replace with our 1 over 4x cubed times du. And again, our goal is what we're looking for is that our x's drop out, so we just have an integral in terms of u. So here, our 4x cubed is going to cancel with this 4x cubed. So what we have is the integral just of u to the fourth, du. And now we can go ahead and anti-differentiate it. It's going to be 1/5 u to the fifth plus c. But we're going to go one step further and resubstitute for u. So I'm going to have 1/5 times x to the fourth plus 3 to the fifth power plus c. And again, we won't do this for every problem, but remember, it's easy to check these just by differentiating. So I'm going to put that here. If I were going to differentiate this, I'd have to work from the outside in. So the first thing I would do is take my exponent and multiply it by the coefficient. So I'm just going to end up with 1. My inside is going to stay the same. My exponent decreases by 1. And then I would multiply by the derivative of the inside, which would be 4x cubed. Again, that c is just a constant, so its derivative is 0. So I would end up just with 4x cubed times x to the fourth plus 3 to the fourth power. And since that matches the function in my integral, I know I've done this correctly. Okay, so for number 2. Now, this one we have to think of a little bit differently. I want you to realize that this is the same as saying the integral of 20x cubed times 5x to the fourth minus 3 to the negative 1 times dx. So now I think with that negative 1, it's easy to see that our 5x to the fourth minus 3 is what would cause chain rule here. So that's what we're going to pick for u. 5x to the fourth minus 3. I'm going to find du is going to give me 20x cubed, and already I'm happy because I know that's in here, so I know they're going to cancel. I need my dx here, and so dx is going to be 1 over 20x cubed times du. So I've got all the pieces that I need. So now my integral, I have 20x cubed over my 5x to the fourth minus 3 is what was u. And dx, I know, is 1 over 20x cubed times du. So my 20x cubes are going to cancel out, and what I'm left with is the integral of 1 over u du. I know that antiderivative is the natural log of the absolute value of u plus c. And so our answer, resubstituting, we have natural log of the absolute value of 5x to the fourth minus 3 plus c. Okay, next one. A lot of pieces going on here, but it should be hopefully by now pretty easy to pick out. Whenever we're taking a trig function and our argument is something other than x, it's some function of x, that's what's going to trigger the chain rule. So here's where, when we see this 3x to the fourth plus 2, that's going to be our u. Now we're going to differentiate that. So du is, let's see, 12x cubed times dx. So dx is 1 over 12x cubed times du. Okay, so now going back to my integral, I have 36x cubed. Then I have the cosecant. Well, all that stuff in there is what we called u. Then I have cotangent. Again, all that stuff is u. And our dx is 1 over 12x cubed times du. So now let's see, I have my x cubes cancel. 36 divided by 12 is just going to leave me with 3. So I have 3 times the integral of cosecant u, cotangent u, du. Now here's where I have to be careful with my signs. I know the derivative of cosecant of u is negative cosecant u cotangent u, so when I anti-differentiate, I have to take that negative into account. So negative 3 cosecant, that's not right, cosecant of u plus c, or negative 3 times the cosecant of 3x to the fourth plus 2 plus c. Okay, last one on this page. When I'm looking here now, e to the 5x cubed minus 1, this piece right there is what's going to trigger our chain rule. So that's our u. So u is 5x cubed minus 1. My du is going to be 15x squared dx. And now dx is 1 over 15x squared times du. So now I have the integral. I'm going to do it under here just so I don't run off the page there. Let me scoot this up so you can see what I'm doing. So I have the integral of negative 60 x squared times e. Again, that 5x cubed minus 1 is my u. And dx is 1 over 15x squared times du. So now I can cancel my x squareds. 60 divided by 15 is going to give me a negative 4 here. So if I simplify, what I'm left with is negative 4 times the integral of e to the u du. So my antiderivative is negative 4 e to the u plus c. And resubstituting, we get negative 4 e to the 5x cubed minus 1 plus c. All right, let's keep going here with number 5. All right, so I find my u first of all. I know if I have 4 to the 5x squared plus 3, that would trigger chain rule. So my u is 5x squared plus 3, which is going to make my du equal to 10x dx. And then dx is going to be 1 over 10x times du. So here we have our pieces that we need. So now I have the integral of 50x times 4. All this stuff is what was my u. So I have 4 to the u, and then dx is 1 over 10x times du. I'm going to simplify. My x's are going to cancel. 50 divided by 10 is just going to give me 5. So what I have is 5 times the integral of 4 to the u du. So now I have to be careful when I'm antidifferentiating, and here's where you really just need to know your antiderivatives. This is going to give me 5 times. Now, my antiderivative is going to be 4 to the u over the natural log of 4 plus c. I'm going to go ahead, I'm just going to put my constants together. So 5 over the natural log of 4 times 4. My u was to the 5x squared plus 3. And then plus c is my antiderivative. Again, I think this one's worth doing a check on because I know this part always kind of throws people off. So let's just quickly go through a check. I have a constant times a function, so my derivative is going to be my constant times the derivative. My derivative, remember this is like our a to the x, so I have 4 to the 5x squared plus 3 times the natural log of 4, and then times the derivative of my inside here, which is going to be times 10x. So if I were to simplify it, my natural log of 4's cancel out. I have 5 times 10x is going to give me 50x times 4 to the 5x squared plus 3. And again, since this function matches what was in my integral up here, I know I've done it correctly. All right, so the last few we're going to do are some definite integrals, so practice with switching those limits of integration. We start off with the same process. We find what would trigger our chain rule, and that's our u. We differentiate, and then we solve for dx. Okay, so now we take our pieces and we're going to substitute. So now I have the integral. I'm going to leave my limits alone for right now. I have negative 6x times u, and that's squared. And then my dx is 1 over 6x dx. Now I'm going to find my new limits. And remember, we said we take our function u and we evaluate it at those limits. So u of 0 is 3 times 0 squared plus 1, which is going to give us 1. So my new upper limit is 1. U of negative 1 is 3 times a negative 1 squared plus 1. And that's going to give me 4. So my lower limit is going to be 4. Now I'm going to simplify, so this is going to go away. I have the integral from 4 to 1 of, let's see what's left here. Oops, I'm sorry, when I substituted this, this should have been a du. So now I have negative u squared du. So my antiderivative is negative u to the third over 3 from 4 to 1. So I get negative 1/3 minus, let's see, negative 64 over 3. And so I'm going to get 63 over 3, or 21. All right, let's see if we can get a couple more in here. All right, number 7. Now I'm going to switch. I'm going to kind of move away from using colors. Hopefully now this process is becoming a little more routine, and as we move towards the AP test, they're not going to allow you to have colored pens, so I kind of want to move away from some of this color coding. You can still use it if it helps you to visualize it, but in the notes I'm going to start moving away from it. So let's see. U is going to be here in our denominator, x squared plus 1. So du is 2x dx, and so dx is going to be 1 over 2x times du. So we still take all of our pieces. Again, I'm going to leave my limits alone for right now. I'm going to have 2x over my u squared, and then my dx is 1 over 2x times du. Now for my new limits, I have negative 1 here, so I have negative 1 squared plus 1 is going to give me 2, and then u of negative 3 is going to give me, let's see, negative 3 squared plus 1 is going to be 10. So my upper limit is 2, my lower limit is 10. Now I'm going to simplify, so I have the integral from 10 to 2 of 1 over u squared du. I know 1 over u squared is u to the negative 2, so if I add 1, I'm going to have u to the negative 1, and I'm going to divide by negative 1. And I'm going to evaluate that from 10 to 2. So really that's negative 1 over u from 10 to 2. So I have a negative 1/2 minus negative 1/10. So let's see, if we make a common denominator, I have negative 5/10 plus 1/10, which is going to give me a negative 4/10 or a negative 2/5. All right, last but not least, here we go. I have a trig function under my square root, so that's my obvious choice for my u. Du, we differentiate it. Next, we solve for dx. Okay, now we head back to our original integral. So I have the integral square root of u times secant squared of x, and then my dx is 1 over secant squared of x times du. I'm going to find my new limits of integration. So I have tangent of pi over 4, which I know is 1, so that's my new upper limit. Then u of 0 is tangent of 0, which is going to be 0. So now my secant squareds cancel out, so I have the integral from 0 to 1 of the square root of u du. So I'm going to anti-differentiate. This is u to the 1/2, so I'm going to have u to the 3/2. So it's going to be 2/3 times u to the 3/2 from 0 to 1. So I get 2/3 times 1 to the 3/2 minus 2/3 times 0 to the 3/2. And so the value of my integral is just 2/3. So the hope is by now you're feeling a little more comfortable with this process. We'll keep working with it.